In this video, I'll highlight one last helpful circuit tool in the form of an active filter using an operational amplifier. One we'll look at is a low-pass filter, and the other, with just some minor changes to the first, will be a high-pass filter. From there, I'd like to answer some questions that I've gotten via some comments in regards to what tools I use, whether it be on the bench or online. The helpful circuit we're going to look at here is an active filter, in this case a low-pass filter, utilizing an LM741 operational amplifier. There's two resistors in use, both of them with the same value, and two capacitors, one being double the value of the other. You can see here by the mathematical formula how to calculate your cutoff frequency, or FC. As you can see in this graph, the cutoff frequency is where the output of the filter will be 3 dB below the input of the filter. This circuit is expressly helpful in passing only those low frequencies below the cutoff frequency, so you can focus on a certain range of frequencies and filter out high frequencies that may be adding noise to your circuit. Here we can see this circuit in action on the oscilloscope. The input is the yellow line and the blue line is the output. Notice a little slew change on the output. That's because of the slew rate of the operational amplifier. Higher frequencies would need a higher bandwidth and a slower slew rate, or excuse me, a faster slew rate for the operational amplifier itself. As we go up in frequency, we're around 400 kilohertz right at the moment, we see that the output is starting to diminish in amplitude. We'll actually go right to doubling that frequency, 800 kilohertz, and you see that the amplitude is diminished quite a bit on the output of the circuit. Our FC in this case is around 600 kilohertz. If you would rather filter out low frequencies and pass the high ones, for instance, filter out 60 hertz or something like that, which tends to make a noisy circuit, you can use the exact same circuit layout except swap the components around a little bit. Instead of the resistors coming into the input pin 3, you put the capacitors, and the resistors go into the feedback and to the ground positions. The formula is exactly the same, however, and the frequency, your critical frequency, if you use the same components from the low-pass filter, that same frequency would now be your critical frequency for the high-pass filter, except everything above it would be passed equally as well. As can be seen here, the components for this circuit really don't take up a lot of room, so if you do have to do some filtering in your projects, this is a nice, neat, simple way to do it, which gives you some clean filtering that you can utilize. To finish up this video, I'd like to address a question that I get a lot is, what do you use? And this is in regards to what tools do I use, what do I find the most helpful, what tools do I use in the design and experiments that I have in my lab. So I'd like to address some of those questions and show you some of the tools that I find the most helpful. First of all, I like a really good power supply, something 2 channels minimum. This is my lab power supply. It has 2 channels that are variable and 1 channel that is set to 5 volts only. A good output current is required. I like 3 amps. Both my channels here have 3 amps of output, and again they're variable from 0 to 30 volts. So a nice good solid benchtop power supply is a key need in my lab. Next is a soldering iron. I like a benchtop model soldering iron with multiple tips. This one has changeable tips, and this one also has a selectable temperature. I don't like set temperature soldering irons. I like to be able to raise it and lower it depending on what I'm doing. The tips that I use can vary. This one is actually called a mini wave soldering tip. It has a little concave point at the tip, which actually makes it extremely good at doing surface mount soldering. More and more components are going surface mount nowadays, so it's good to have this tip, or at least a very sharp tip, to work in the surface mount area. An extremely important tool to me is my digital multimeter, or DMM. I use different models from Radio Shack in my portable unit to this Fluke here, and I have other Flukes that I use as well. I like to have to where I can do amperage inputs, milliamp and amp, and also the voltage input and ohms. I can do analog or AC voltage, excuse me, and DC voltage, millivolts, and milliamps and amperage. There's a lot of other features on this particular model that you have. You have an output for milliamp range, which is good when you're wanting to simulate a 4 to 20 milliamp input or sensor. There are also some different settings and ranges that give a lot of versatility to this unit. This is an extremely important tool if you want to get into electronics. If you can find an affordable model, an oscilloscope is extremely handy to have in your laboratory. You may not need one as fast as this one, for instance. This one will handle some good fast signals, but lower end models will do just as well. I often get asked how I do my schematics and drawings. A free program that I really like using is Express PCB, shown here. This actually gives you a schematic capture program as well as a layout program if you want to do your own printed circuit boards. It's fairly easy to use, has a good library of parts, and it also has some good tutorials leading you through it, so you can go from schematic to board creation to even sending them out to get built so you can work in custom PCBs for your projects. And lastly, if you'd like an online area to simulate your electronics designs, I recommend Circuit Labs. This program allows you to draw up your circuits and then run different types of analysis, whether they be DC or AC sweep or whatever you need to do. This is a great place to do some prototyping before you actually start working with your breadboard on the bench. Well, hopefully the filter circuits will give you some ideas on some signal processing, and the tools that I've listed will give you some ideas on different things that you can put in your lab or take you in some different directions with your projects. Happy building.